Hello, welcome back to the Math 121 notes. We're going to start a new section here. We're going to start section 4.1, and we're going to be talking about exponential functions. So up here, I want you to guys write this. These are functions. So these are functions where the variable is an exponent, okay? Is an exponent. All right, and so what I want to talk about, I just want to do some like general things here and talk about this. So I've got the function, the general form, and let's write this as f of x is equal to a times b to the x, okay, where a is your initial value. Okay, it's also going to be your y-intercept, okay, and b is your base, okay, and we also call that your multiplicative rate of change, all right, multiplicative rate of change. All right, and a couple things here. If your base b, if b is greater than 1, you have exponential growth, okay? But if b is between 0 and 1, so 0 less than b less than 1, we're going to have decay, all right? And we'll kind of look at both of those here in a second. All right, so in an exponential function, this is the idea, all right? Your exponent is your variable, all right? And so let's look at an example real quick. And what I'm going to do is, let's think of an example, okay? And let's think of the function f of x equals 2 to the x. All right, and what I want to do here is, just plug some values in for x. And so let's make a table here, x and y. If x is, say, -1, all right, and I kind of choose these values for a reason here, but we'll get into that later. If I plug in -1, if I do f of -1, that's going to give me 2 to the -1 power. Now, if I have a negative exponent, then I'm going to write this as 1 over 2 to the first, which is just 1/2. So the y value here is 1/2. If I plug in 0, f of 0 is equal to 2 to the 0 power, which is just 1. Anything raised to the 0 power is 1. Okay, if I do f of 1, okay, plug in 1, it's going to be 2 to the first power, which is going to give me just 2. All right, if I do f of 2, plug in 2 for x, it's going to give me 2 squared, which is 4, y value of 4. And if I do f of 3, it's going to give me 2 to the third power, which is going to be 2 times 2 times 2, which is 8. All right, so I have these numbers here. And what you can see is that these numbers are doubled every time. Okay, that's my multiplicative rate of change. Okay, in a linear function, we add a number to get to the next number, but here we multiply by 2. All right, so if I were to graph this, all right, and I'm just going to draw a simple graph here. And let's do this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 2, 3. Okay, what I have is I have the point, let's plot the point 0, 1. Okay, that's the first one. I'm going to plot the point 1, 2. And I'm going to plot the point 2, 4. Okay, and I'm going to plot the point 3, 8. So notice what you have. You get this curve here. And then if I plot -1, 1/2, I'm going to get a graph that looks like this. All right. And what it does is it's going to shoot up like this. All right. This is growth. Okay. If I had, say, if I wanted to talk about the domain and range of this graph, okay, the domain is going to be all real numbers. Okay. If I put that in interval notation, that would go from negative infinity to positive infinity. If I wanted to talk about the range of this function, what I would do is I would say, well, what's going to happen is that all these y values are going to be above the x-axis. This function is asymptotic to the y-axis. And what's going to happen is that as x goes to negative infinity, the y values are going to approach 0, all right? So the range is going to be the y values are just greater than 0, okay? Or if you put it in interval notation, we can go from 0 to positive infinity, okay? And that's the idea. Now, the other thing I want to talk about are transformations here. If I were to, think about, and let me write this down here. Let me write down transformations. Let me write this down as such. Let me write f of x equals a times b to the x minus h power and then plus k. All right, where h is going to move horizontally. Okay, and it's going to move in the opposite direction of the sign, so opposite of the sign. Okay, and then k is going to be a vertical shift, and that's going to follow the sign, okay? It's not going to be opposite of the sign. All right, so we got that, all right, and I'll let you guys kind of mess with that. But let's talk about exponential decay. All right, let's talk about exponential decay. All right, so let's say that I have this function. Let's say I have f of x is equal to 1/2 to the x power. Okay, notice how my base here is is between 0 and 1. Okay, and that's what tells me that we're going to have exponential decay. And what I want to do here is create another table. So I'm going to do x, y, and let's do this. Let's choose, say, like -3, -2, -1, 0, and 1. All right. Let's first find f of -3. Now remember, when I have a negative exponent, I'm going to get 1/2 to the -3rd power. This is really going to give me 1 to the -3 over 2 to the -3. All right, and when I have negative exponents like that, I want to move them in between my numerator and denominator, and that's going to give me 2 to the 3rd power over 1 to the 3rd power. Well, 2 to the 3rd is going to give me 8. 1 to the 3rd is going to give me just 1. So 8 over 1 is just 8. Okay, and that's that value there. Okay, if I plug in -2, that's going to give me 1/2 to the -2 power, which is going to give me 1 to the -2 over 2 to the -2. Move your exponents around to make them positive, so move them, if they're in the denominator, move them up. If they're in the numerator, move them down. So this is going to give me 2 squared over 1, which is going to give me 4. 2 squared over 1 squared. 1 squared is just 1. So this is going to give me 4. If I plug in -1, okay, so if I do f, oh my gosh. Okay, f of -1, okay, then what's going to happen is we're going to get 1/2 raised to the -1 power, which is going to give me 1 to the -1 power over 2 to the -1 power. And I'm just going to move those around. This is going to be 2 to the 1st over 1 to the 1st, which is just going to give me 2. Okay. If I've got f of 0, okay, plug in 0, I've got 1/2 to the 0 power. Anything raised to the 0 power is just going to give me 1. And then if I take 1/2, I'm sorry, f of 1, so I'm going to take 1/2, raise it to the 1st power. That's just going to give me a value of 1/2. All right, and so what happens here, notice as, in this example up here, how when you plugged in values, when x got bigger, your y value got bigger. Notice how when your x values get bigger, your y values get smaller. This is why we have exponential decay. Okay, and if I graph this, all right, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, and 1. Okay, if I graph the point -3, 8, it's going to be up here. If I graph the point -2, 4, 1, 2, 3, 4 is here. 1, 2, 0, 1, and then 1 and 1/2. And what ends up happening is you get this exponential decay where it goes in the opposite direction, okay? So you've got two options here, okay? You're going to have either exponential growth or exponential decay, okay? And it depends on the value of b that you have, all right? The last thing I want to talk about is the number e. E is a number, okay? E is a number, okay? It is a naturally occurring number. I won't get into how we actually get e because that's a pretty advanced problem, but what we talk about is this natural number that is a naturally occurring number e. And e is approximately 2.718. It's kind of like the number pi, okay? And what you'll notice is that on your calculator, you actually have an e button, all right? So what you'll do, with a compound interest formula type thing, is you'll have a function like this, like f of x is equal to, say, like 1,000 times e to the x power, okay? Where e is your base, okay? And so you want to make sure that you use that on the calculator. So anything that involves e, as of right now, is going to be a calculator question. Further on down the road, when we talk about logarithms and stuff like that, we're going to use e a lot, and we're just going to write it like e. So similar to how we use pi as 3.14, e is going to be another number like that, okay? So that's all I got for this. Let's go ahead and do all these problems on this page and then the next, and we'll talk to you soon. Thanks a lot. Bye.